Hi, welcome to the video guys. My name is Pushpinder Gill and today we are going to do sequence and series, right? So this is a pretty basic video on sequence and series, but when I say basic, I do not mean it's not important. It's actually a very important video for sequence and series. No matter what exam you're giving, no matter what you're doing, if sequence and series is part of that exam, this is something that you have to watch. So this would be the web address where you can explore more about us. That is perfect-scores.com. A lot of exciting stuff coming here. This would be the Facebook page to give us your valuable like. And this is the email address where you can give us your valuable feedback. So let's go ahead and get started, guys, right? So, I'm going to straight away hit the button here. I'm going to start with a general sequence. Now, what do you mean by any sequence, right? So generally I'm talking about, let's suppose if I say that this is a sequence, that 2, 4, 6, 8, 10, 12. So this is a sequence. You can clearly see that the sequence is actually increasing by a certain number. So usually general sequences are defined in terms of a single equation. So let's suppose if I say that a of n is equal to n plus 2, right? So if I want to define a general sequence like this, then usually the first term of the sequence would be a of 1, which is going to be 1 plus 2, which is equal to 3. And a of 2 is going to be 2 plus 3, that is equal to 5. And a of 3, sorry, it's going to be plus 2 again, that is 4. A of 3 is going to be 3 plus 2, that is equal to 5, right? So this over here, I have defined a general sequence by this over here. So this n denotes the number of terms, right? And you can actually define a general sequence in so many ways. You can say that, let's suppose a of n is actually equal to n square plus 4. It can be like this also. And then I'm going to have a of 1 to be equal to 1 square plus 4. I'm going to have a of 2 to be equal to 2 square plus 4, right? So general sequence can be of any nature, can be of any form, right? So we're going to make a special video on general sequence in the coming videos here. So I just wanted to introduce sequence to you. The sequence does not mean that it has to have a constant difference, or it has to have a common multiplication point here. General sequence just means that I have defined a sequence that a of n is equal to n minus 2, and I'm just keep on defining what is the first term, what is the second term, and what is the third term, right? So this is what a general sequence is. Now coming to the most important part, coming to one of the most important sequence that is tested in most of the exams, is called the arithmetic progression. Now what is an arithmetic progression? An arithmetic progression is a sequence where each term increases by a common number, right? So let's suppose if I have this is an arithmetic progression here. You can clearly see that each term is increasing by a factor of 2. Each term is increasing by a factor of 2. So this over here is an arithmetic progression, right? So coming down to another important part is, it's generalizing this arithmetic progression. So let's suppose, if I just erase all the screen here, let's suppose that the first term is a. We're going to usually denote the first term by a, and the second term is a plus the difference between each term, and the second term is going to be equal to a plus 2 times the difference between each term, and so on, right? So this is how this is going to be. But if I want to calculate the nth term, right? So if I want to calculate the nth term, so you can clearly see that the first term is equal to a, the second term is equal to a plus 2 minus 1 into d, the third term is equal to a plus 3 minus 1 into d. You can clearly see this third term is equal to this. So I can clearly say that the nth term is equal to a plus n minus 1 into d. So this is how I define my nth term, right? So this is how I usually define my nth term. So let's suppose if I say what is going to be the 47th term. The 47th term would be a plus 46 into d. What will be the 89th term? 89th term would be a plus 88 into d, right? So the nth term is given by a plus n minus 1 into d. So suppose you're understanding this point over here, right? Let's kind of explore more on this part. So now we have our arithmetic progression to be a plus d, a plus 2d, and all the way till a plus n minus 1 into d. So right, what I'm gonna do is I'm gonna do a little bit of back solving here, right? I'm gonna show you an arithmetic sequence, let's say 2, 4, and 6. Now what is the average of 2, 4, and 6? The average, the arithmetic mean of 2, 4, and 6 is 4. So try and calculate that. 6 plus 4, 10, 10 plus 2, 12, 12 divided by 3 is 4. What is the arithmetic mean of 2, 4, 6, 8, and 10? That is going to be 6, right? What is the arithmetic mean of 2, 4, 6, 8, 10, and 12? That is going to be 7, right? So you can even pause the video and check out what is the arithmetic mean of these numbers. I'll be right. Now what am I trying to say here? Indirectly I'm trying to tell you something, that when the numbers are in arithmetic progression, the middle number is equal to the mean. Now why is that? Why is the middle number equal to the mean? Because you can clearly see that the arithmetic progression is distributed symmetrically. That means the deviation on the right hand side is going to be equal to the deviation on the left hand side, which means the middle number will always remain to be equal to the mean, right? No matter what happens. There's another way of finding the middle number. The another way of finding the middle number is the first number plus the last number divided by 2. You can clearly see this is equal to 2 plus 6 divided by 2. You can clearly see the mean over here is 10 plus 2 divided by 2. You can clearly see that the mean over here is 12 plus 2 divided by 2. So another way of calculating the mean is the first number plus the last number divided by 2. So this is what I want to generalize when it comes to arithmetic progression, that the middle number is the mean, and mean is also calculated as the first number plus the last number divided by 2. Now let me try to improve more from here, talk a little bit more about arithmetic progression. So we have this as the arithmetic progression here. Now let's suppose if I want to calculate the sum of an arithmetic progression. Now what is sum? Sum is equal to average of the sums into the number of terms, right? So what is sum? Sum is equal to the average into the number of terms. So what is the average of any general arithmetic term? That is going to be the first number plus the last number divided by 2. So that is going to be equal to the first number plus the last number divided by 2. And I have to multiply this by the number of terms, which is actually equal to n here. So if I kind of explain this up, so this is going to come down to a plus a times n minus okay, so I need to have a plus here. So that is going to be equal to a 2 times a plus d into n minus 1 divided by 2 into n. So the sum of terms would be given as n by 2 into 2a plus the difference between each term into n minus 1. So this is going to be equal to the sum of terms. So let me just write down whatever we have discussed here into one slide. That is that the nth term of any arithmetic progression would be given as a plus d into n minus 1. The sum till n terms would be given as n by 2 into 2a plus d into n minus 1. And the mean is equal to the first number plus the last number divided by 2. And mean is also equal to the middle term. One more thing that I want to say, that arithmetic mean of any two terms, let's suppose a and b, is given as a plus b divided by 2. Now what do you mean by arithmetic mean? Let's suppose I have a here and b here. There is a number in between a and b that is equidistant from a and equidistant from b. How do you get that? You get that by a plus b divided by 2. Let's suppose I want you to find the arithmetic mean of 10 and let's say 8. So the arithmetic mean of 10 and 8 is going to be 10 plus 8 divided by 2, which is equal to 9. And you can clearly see that 9 is equidistant from 10 and equidistant from 1. This will help you to understand the expression, understand this graphically, visualize it, right? And you can be more logical when it comes to arithmetic mean. So I suppose you're understanding what I'm trying to say here. These are the important things when it comes to solving any question. And I say any question when it comes to arithmetic progression, right? So I've jotted down a couple of questions for you guys. Let's go ahead and solve those questions using this. I hope you've noted down what we've discussed here, the important points. All right. Now the question says that find the sum of odd integers from 1 till 2001. So the set is going to be equal to 1, 3, 5, 7 all the way till 2001. Now rather than complicating yourself and using the formulas, you can actually find the average of these terms. So the average is going to be equal to the first number plus the last number divided by 2. So the average is going to come down to 2000 by 2, which is 1001. And you can clearly see this 2001 is the nth term, that is equal to first term plus the difference between each terms, which is d, into n minus 1. So rather than you trying to visualize how many terms are going to be there, you can just simply use the expression here. Very, very handy. What I've used here, that the nth term is equal to a plus d into n minus 1. So this 2000 is going to be equal to 2 times n minus 1, and n minus 1 is going to be equal to 1000. That means n is equal to 1001. Now I have the number of terms and I have the average. That means the sum is going to be equal to number of terms into average. That is going to be equal to 1001 into 1001. So suppose you've understood what I'm trying to say here, guys. Moving forward to the next question. Now the question says that find the sum of all the natural numbers lying between 100 and 1000, which are multiples of 5. So what is the first number? That is going to be 105. The next number is going to be 110, and that is going to go all the way till 995. Again, it's a similar looking question, right? The average is going to be equal to the first number plus the last number divided by 2. So that is going to be 995 plus 105. So that is going to be equal to 1100. So 1100 divided by 2 is 550. So the average is equal to 550. Now the only thing required for us to calculate is the number of terms. So the nth term would be given as the first term plus the difference between each terms into n minus 1. That is equal to 995. So 5 times. So what I'm going to do is I'm going to eliminate 5 from everywhere. 2 and 1 and 1 and 4 and 9. That is going to be 9. 4 and 9 is going to be 9. Just double checking my expression here so that I haven't made any kind of error. That's fine. So n minus 1 is going to be equal to 199 minus 21. N minus 1 is going to be equal to, so kind of 200 minus 22, which is going to be 178. So 178, and the number of terms is going to be equal to 179. Now what we have to do is we have to find the sum. The sum is equal to average into number. That is going to be equal to number of terms into the average, which is going to be 179 into 550, right? Alright, so I suppose you've understood this one here, guys. Moving forward to the next question. So the question says that if the sum of the first p terms of an arithmetic progression is equal to the sum of first q terms, then find the sum of p plus q terms, right? So I'm going to set up, so if the answer options are, if this is a multiple choice question and the answer options are variables, then you should rather plug in there. But I'm going to use a little bit of math to calculate this, right? So the sum of first p terms of an arithmetic progression. So let's suppose that the first term of an arithmetic progression is a. Actually, there are two ways to solve this question. Either you can go crazy over algebra, or you can actually plug in as well. Let me show you how you go crazy over algebra here. If the sum of p terms of an arithmetic progression, so what will be the sum of p terms? That will be p by 2 into 2 times a plus difference between the terms into p minus 1, right? That is going to be equal to sum of q terms, which is equal to 2a plus b into q minus 1. And what you're supposed to find? You're supposed to find the sum of p and q terms. That is going to be equal to 2a plus d into p plus q minus 1. So these two equations is what you have to manipulate and get your answer. Or what you can do is you can actually go ahead and plug in. Let me just show you how to use this plug-in method. Let's suppose the question says that what is this if the sum of first p terms is equal to the sum of first q terms. Now this is something you can only do when you have multiple choice questions, right? This is something that you're supposed to do when you are in like in your K-12 examinations or in your 12th or 11th standard. So let me say that this is the arithmetic progression: 10, 5, 0, negative 5 and negative 10. Let's suppose this over here is our arithmetic progression. So what is the sum of first term when p is equal to 1? When p is equal to 1, sum is equal to 10. And when q is equal to 4, what is the sum of this plus this plus this plus this? The sum is again 10. So the question says that the sum of p terms is equal to the sum of first q terms. The sum of p terms is equal to the sum of q terms. So what is the sum of p plus q terms? What is the sum of 5 terms? If you add all the 5 terms all together, the sum is going to be equal to 0, which is going to be my answer. And if you try to manipulate and if you try to get algebra, if you try to manipulate this, you will get this, that 2 times a plus d into p plus q minus 1 is actually equal to 0. This is what you're going to get if you manipulate. It's a very long one-page manipulation. I'm going to refrain for that. I suppose you'll be equipped with algebraic skills to manipulate this equation, right? So, but again, if it's a multiple choice question, don't even bother using algebra here, right? If you were my student, I would definitely tear up your paper if you use algebra and it's a multiple choice question. You have to plug in on this kind of question when it's a multiple choice question. Sure. Anyhow, moving forward to the next question there. Okay, so let's go ahead and do this question. So this question says that x to the power n plus y to the power n is the arithmetic mean between x and y. So what do you mean by arithmetic mean between x and y? I mean to say that x plus y by 2 is equal to x to the power n plus y to the power n divided by x to the power n minus 1 plus y to the power n minus 1, right? Because the arithmetic mean is equal to this. Now I've got to find the value of n. So what I'm going to do is I'm going to take this to that side and I'm going to take this to that side. So this is going to be x plus y times x to the power n minus 1 plus y to the power n minus 1. That is going to be 2 into x to the power n plus y to the power n. This over here, if I multiply x by this is going to be x to the power n, and then it's going to be x times y to the power n minus 1 plus y times x to the power n minus 1 plus y to the power n is equal to 2x to the power n plus y to the 2y to the power n. So that is going to be x into y to the power n minus 1 plus y to the power x to the power n minus 1 is equal to x to the power n plus y to the power n. I kind of take them to this side. I have this as n here. Okay, so let's go ahead and do this question. I can actually do this question two ways. I can do it the MCQ way, alright, or I can do it the algebra way. So just remember, x raised per n plus y raised per n is the arithmetic mean of x and y. Okay, I just have to say that x and y are distinct. That's how the question should be. Alright, so let's use algebra here and let's use multiple choice question way. So if I want to use algebra, I'll simply say that the arithmetic mean of x and y is actually equal to x, this, right? I can take this to that side, I can take this to that side, and I'll have x into x into x to the power n minus 1 plus y into x to the power x n minus 1. So I'll write this as x plus y times x raised per n minus 1 plus y raised per n minus 1. That is equal to 2 times x raised per n plus y raised per 2 times y raised per n. So I kind of open this up. This is going to be x raised per n plus y raised per n plus x into y raised per n minus 1 plus y into x raised per n minus 1. That is equal to 2 to the power x raised per n plus 2 into y to the power n. Now this and this is going to go to that side. I'm going to have x into y to the power n minus 1 plus y into x to the power n minus 1 is equal to x to the power n plus y to the power n. I'm going to bring this to that side and bring this bring that to the other side. I'm going to have x to the power n minus 1 times y minus x to the power n is equal to y to the power n minus y into x to the power n minus 1. I kind of use this space here. If I take x to the power n minus 1 common from the left hand side, I'll be left with y minus x. And if I take, so this is y here and this is x here. If I take y to the power n minus 1 common from here, I'll be left with y minus x. And from here, this and this will get eliminated. I'll have x over y raised to the power n minus 1 is 1. And since x and y are distinct, they cannot be equal to 1. That means n minus 1 is actually equal to 0, which means n is equal to 1. So that's the algebra way of doing it. The only thing that the only thing was required from your end, in terms of reasoning, was this part, right? That the arithmetic mean of x and y is equal to this, and you just go boom, boom, boom of some sort of manipulation. But when it's a multiple choice question, life becomes a little bit easier. What you can do is you can actually use the answer options. One of the answer options lying there would be n equal to 1. And what you got to do is you got to plug this answer option back here. X raised per n, x raised per 1 plus y raised per 1 divided by x raised per 1 minus 1 plus y raised per 1 minus 1 is equal to x plus y divided by 2. Bingo, that's my answer, right? So when it comes to multiple choice question, it's a whole lot of game. It's a whole different game. You cannot use the same approach in a multiple choice question. But yeah, if you want some marks to be given for steps, that's the way to do it. But if you want to get score on the basis of multiple choice questions, that's the way to do it. Right? So I suppose you're understanding what I'm trying to say over here. Alright, so thank you very much for watching this video, guys. We're going to be coming up with geometric progression in the next video. So I suppose you've understood this. We'll be solving a lot of complex examples for arithmetic progression. And remember, this is the basic math course, which is available on perfect-scores.com. You can watch all of our videos right here. So this will be about the video, guys. Thank you very much, and I'll see you in the next one.